No, there's a crystal of germanium there that comes into contact with a very fine wire. And that collects the electrons. Then the flow is controlled by radio impulses.
You understand that?
If you love listening to this show, please consider giving a rating and a review on Amazon Alexa or wherever you listen. We want to continue bringing you this amazing content, and part of our ability to do that means that we need a big audience. Now, it may not seem like much, but rating and reviewing the show will help more people find us, just like how you found this show. Simply on any podcast platform, search for our show, scroll down to the bottom, and push 5 stars. It's that easy. Thanks for supporting the show. Today, I'm joined by Ed De Reyes, who is the CEO of Sabrewing Aircraft Company, a manufacturer of unmanned heavy lift commercial cargo air vehicles.
Thank you, Scott. I appreciate that. Thank you for having me.
So we're just having a kind of a casual conversation about the fact that you're a retired Air Force pilot, and one of the things that also comes up in conversations is that you're a experimental test pilot and flight test engineer, and oftentimes you get asked, what was some of the kind of scariest moments that we've had. So I'm just gonna, kind of put some parameters around that. But if you could share anything from kind of your span of experience from Air Force to some of the things that you've done for the primes and contractors, that might be helpful.
Sure. I actually started out life as an enlisted guy in the Air Force, and then afterwards, after I got my undergraduate degree in electrical engineering, then I went on to become a flight officer in the Air Force. And so, and then I naturally gravitated towards flight test. I think everybody in my generation wanted to be an astronaut. And the way you got there was by being a test pilot and being heavily involved in flight tests. So it was kind of a natural progression. Of course, once I got my graduate degree in aeronautical engineering, that's really what I want to do. It actually even took precedence over the wanting to be an astronaut. So for me, there have been incidences where they were, made your heart rate go up, I should say. But in reality, I don't think. I think the scariest experience I ever had wasn't even in the Air Force. It was actually as a civilian test pilot. In a crash, an air mishap on takeoff, the aircraft was not supposed to take off, and it actually did get in the air. And I was able to control. It was basically out of control, but I was able to control it enough to do what they call a controlled crash, which I walked away from. Luckily enough, I had a few broken bones, but still, it was not, life-threatening or anything else. But civilian flying for flight tests, especially for a lot of the startups that are coming out these days with their own aircraft, is a little bit much. Not a little bit. It's much more. I should say it induces a higher heart rate because you don't have the same kind of safety gear you have. Even though I had a parachute on, I was too low to eject from the aircraft. I couldn't even eject if I wanted to because it didn't have an ejection seat. So that was probably the scariest thing that ever happened to me.
All right. Well, we will save those stories for maybe perhaps another episode. Maybe when we invite you back.
Great,
let's talk about the fact that you've done the Air Force, you've done commercial, but it was really oriented towards essentially carrying people in particularly. So I'm curious as to why shift from people to cargo instead.
Right. It actually was kind of a progression in itself. I had done cruise missile testing way back when I was a civilian. When I was an enlisted guy in the Air Force before I became an officer. So, taking from that experience initially, I was part of the navigation system team on that. But then later on, as time went on, my specialty was really. I thought I wanted to go into engines and in that. And as a matter of fact, my graduate thesis was in propulsion. But as it turned out, I ended up, because of my background in electrical engineering, ended up doing a lot more navigation systems, because those were the software, hardware are things that always change in aircraft as generations go on. And I was lucky in that I had a lot of guidance from my graduate advisor, who happened to be a Navy test pilot, a really brilliant guy. He's long since passed on. But anyway, he said, no, you really want to stick with the software portion, because aircraft in the future, which is now, aircraft in the future they'll be changing software, they'll be changing hardware, but they really won't change the basis of the aircraft itself. And so that was really a smart thing to do. But anyway, long story short, the last job I had working for someone, even as a consultant, was in the Global Hawk program, which of course is Northrop Grumman, and it's a very high altitude civilian, or I should say very high altitude aircraft, but it flies through national airspace. It flies through a lot of national airspace. So that exposure to that gave me a lot of knowledge on how we would certificate an aircraft like that for the FAA, or even for the military in general. But as time had gone on, after I left Northrop Grumman, I founded a little civilian cargo airline. Well, it was a charter airline, which we flew both civilians or people and cargo, but a lot of cargo. Mostly the thing that paid our bills for the most part was flying cargo. And it was born of that want to produce a cargo aircraft. And I really learned there too. At the time, people were talking about using drones. They were strapping, burritos and Band-Aids and things to drones and flying them, a certain distance and landing them there. But everybody I spoke to said, that's great, but there really isn't a market there. And I think that's still the case today. The market there is extremely limited. Air cargo, though, the real funding, or I should say the real profit, comes from the more that you can carry, both in weight and size. And so that makes it was a lesson that I learned back then, because I was always looking for an aircraft that could carry more weight, more big size cargo, because that's where the money was. And so I translated that into a civilian aircraft project that was an unmanned drone. That too was born of the fact that a lot of times I'd be in this twin engine Cessna airplane in weather that was just horrific, trying to get a load of auto parts, engine blocks, or paperwork, books, things of that nature that I had to get to another location, critical locations. So it made, I can't tell you the number of times I would shoot an approach, what they call, make an approach into an airport where the visibility was at minimums, and it was, very high winds, and, in some cases snowing, just the weather was terrible, and thinking to myself, there's got to be a better way of doing this. So that was also the seeds of how this started. And so the thought was, hey, I think we can build an aircraft. And going back to knowing we could do it with Global Hawk, I thought we can build an aircraft that can certainly do this now. And even Predators, they're not specifically a cargo aircraft, neither is Global Hawk, but Predators have been flying in the national airspace for 25 years. Same thing with Global Hawks. They've been flying for 20 years. And so the safety record of those aircraft is paramount. I mean, they've never, in the history of any form of transportation, no other segment, air transportation really is the safest. If you look on a per capita basis, or how many people they move throughout the year, what the fatality rate is on that, it's still the lowest of any transportation system. And then if you look at the UAV section, between helicopters and those are the large ones, the group, what they consider Group 5, or the heavy UAVs, have no fatalities. And that's actually incredible if you think about it, and going back 20 years. So nobody's ever died from a crash of one of these things ever. And so, knock on wood, that will continue to be the case going forward, but it's a very safe way of doing things. Hence, that was really the seminal criterion that really brought us to this point, that, why we decided on a heavy cargo aircraft.
Yep. Well, thank you for kind of walking us through that process and the accumulation of the experience that's brought you here. And I kind of go back to one of the things that you share, which is your prior mentor that really, even at that decades ago, saw that really the hardware, of course, is hard, but having competency and mastery over the software and firmware was even more important, and certainly that has been the case. So thank you again for walking us through that. So as far as Sabrewing Aircraft Company, I think let's get into some of the specifics. And again, I think you start to cover some of it, but many drones tend to focus on smaller packages. I think Amazon indicates that their average size packages are less than 5 pounds, for instance. I think the largest, generally, drone cargos usually don't go up beyond kind of the 100 pounds. Yet your Regal regional cargo UAV has a VTOL payload capacity of some 5,400 pounds over a distance of 1,850 kilometers at a cruise speed of 200 knots. Tell us the significance of that and why, and what are the specific use cases that you were referring to when you said carrying more payload at a lower cost is better?
The when you look at the business case, your cost to spread that, just say it costs $10 to move a 5-pound package. That's, I'm pulling it out of the air here, but if $10 to move 5-pound package, it's roughly $2 a pound. But when you look at a large cargo aircraft, even if it were $1 a pound, if you can move 2,000 pounds, the profit is there. You can do it. You can carry much more weight in a single flight than you can in many single flights. To do $10 for 2,000 flights is great, but you may not have enough of a customer base to do that. So that was one of the things when Oliver, my partner, and I first started to look at this segment of the cargo market. There were a lot of ifs and whats and how do we do this, but I knew from my experience in the cargo aircraft industry what made sense to me, but I really needed to speak with other cargo operators, the FedExes and the UPSs and even the Amazons, people like that. You Amazon make your living by delivering bulk cargo, or really in this instance, bulk packages to people, lots of packages to people. But the one that's always operating 24 hours a day are their cargo aircraft, and they're, everything else, they have the trucks and everything else that carry lots of packages, not single packages. And so in talking to them, they were the ones that really drove that requirement to go higher and higher. Even some of them, I can't say who, but some of the people that are now testing the 5-10 pound loads in the market are looking at more as would it be possible to get a Part 135, which is the cargo carriage, or the on-demand cargo, air cargo. Is it possible to do it on a smaller drone? But in reality, they're looking at the market saying that internally they're saying, well, this is cool. We know we can do this. We're really looking at carrying much more, because traditionally that's how they've made their markets. They have lots of market data. And even us in general, when we pitch an investor, we always have to go back and say, we're blazing an unmanned air cargo here, but in reality, the air cargo market is not only has over 100 years of data, but it's not like UAM or the urban air mobility. We don't know what that market's going to be like. The only ones that are really saying it's going to be healthy is Uber. And even Uber's not looking as much at that market segment really catching on much before 2025. Everybody's still looking at cargo. You see a lot of companies that before had said, we're going to build this UAM aircraft that's going to be able to land and take off vertically. Now they're pulling back on their plans to do that, and they're introducing cargo aircraft because they realize that the segment is there. It's easier to get certificated. You can carry a lot more weight, and it's much more profitable than a manned aircraft. So those are really the things that cargo not only has the history, but it's got a good projection going forward into the future. And so all those things combined really were, again, things that drove a significant portion of the design of our aircraft and why we decided to go unmanned cargo.
So I want to explore a couple of dimensions. One is this notion of on-demand. Some of it's being driven by, I think, the consumer side. So in particular, Amazon's, expectation setting with consumers that you can start to have not just 2-day, but 1 day, and eventually 1 to 2 hour delivery. So there's certainly that kind of expectation that's building up on the consumer side. And I would imagine on the enterprise side, there's also, pressure to move towards on demand as well as almost near time delivery. But can you also share a little bit about use cases where this makes sense? So though you're taking some market share away from the traditional cargo carriers, the load capacity certainly isn't as large as the UPS or the FedEx cargo planes. So what exactly is this really well suited for? What kind of high value products, whether it's semiconductor chips or certain pharmaceuticals? What are the kind of the sense of urgency that makes it necessary to fly versus truck it in?
There's a lot of reasons. First of all, we're considered a regional air cargo carrier, similar to, for example, Cessna produces two aircraft called the Caravan, and the other one is the Sky Courier. As a matter of fact, we started our design, I think, before Cessna had started to introduce their Sky Courier aircraft, and it's surprising because a lot of their assumptions that they came to were assumptions that we had, or I should say, design features that we already knew that we had to incorporate in the aircraft. So their aircraft, it's a twin-engine turboprop high wing. It is able to take unit load devices, the cargo carriers that typically fit underneath the aircraft, and it's able to carry a load of 6,000 pounds. But it's a fixed-wing aircraft, and so I was talking with a Cessna representative a while back, and he actually was not hostile, but he was not necessarily friendly when we first started our conversation. But as we left, I think he understood where we were coming from, was no longer sense that hostility. His main thing was, you're going into competition with Cessna. You do understand that. And what I said was, no, we're not. And the reason we're not is that we're able to take cargo to places that are so remote right now that not even fixed wing aircraft can get in. And so we see ourselves as an adjunct, and we're able to open up new market segments. There will always be a need for those aircraft, like the Sky Courier and even the Caravan, and mainly because they can carry people. And that is a needed segment. That really is very important. We can't carry people, but we can get into places that neither one of those aircraft can get into. So a company who currently owns Sky Couriers or Caravans or any of Pilatus or any of those that can carry the same amount of payload or slightly less payload than we do, they can still go to the places they're going to. We can introduce new markets. We can open new markets that sort of exist right now. There's a need for cargo in those markets. However, they cannot get them cargo for whatever reason, especially when the weather is bad. And we used as one of our first cases, Alaska. And the reason we used Alaska, I've got a kitty cat here that insists on being part of the joys of working at home. But anyway, we used Alaska as our primary, kind of focused on what it would take to do this in Alaska, mainly because only 17% of the communities in Alaska have roads and are even close to an airport. So that means 83% of their communities don't have easy access to roads or railroads or ports or even airports. But there's still a significant portion of the population that lives there. So how do you get them batteries and books and Amazon packages and things like that? The best way of doing it, and there are hundreds, if not tens of hundreds of miles away from the nearest place where they can buy these things and carry it out. So you still have to be able to service that. And it's not just Alaska, it's Indonesia, where you've got, I think it's 18,000 small or 12,000 small islands that are all populated, but they don't have runways. They don't even have ports where you can deliver things. And there's growing segments of the population. So the need really is there. Amazon jungles, sub-Saharan Africa, even the Middle East, where long stretches of desert, but significant portions of people live there. You still can't even get a fixed-wing aircraft in there. If you can't drop it, it's not going to be delivered in a timely manner. So that's really the thing that drove it. And they were much more so than building to sustain a village of 200 people. It's almost impossible in Alaska, for example. It's almost impossible to use a small, 1, 5, 10-pound drone, because even then, okay, so you can go 100 miles, but you're still 250 miles from the closest place. So, but it isn't just that. It's going to be, you're going to need, all sorts of things. You're going to need to carry a significant load, and that significant load is really the market segment we're after, and it happens to be bigger than the last mile. What the big companies have been experimenting with, and they recognize that too, I should say.
Well, I think you've been mostly talking about the vertical takeoff capability with the weight or the payload feature. However, I think certainly the other XY axis is the urgency, the importance. So whether it's a fire or natural disaster issue, let's say for instance, we haven't talked about defense or DoD related types of use cases, but this notion of on demand, being responsive to something that's urgent, that you can't afford to wait, let's say 6 hours, 8 hours, or 24 hours for a truck to come in. You need that within the next half an hour to less than an hour, for instance. So that timeliness becomes very critical.
Right.
What are the kinds of goods or things that have gone into these containers?
Just about everything. I mean, it's a you mentioned it before. Semiconductors are a big one. Some auto part. Most industry, if they have a line that goes down, it costs them a lot of money. Even drilling companies or petroleum companies who are drilling wells, if they have I can take the case again of Alaska, where they may have a well that shuts down because the bit broke, the drill bit broke, and so they will. It's literally costing them almost $1 million a day to be shut down. So so they spend $300,000 flying one out, or 400, even $500,000 flying one out direct from Houston to get it there ASAP in the middle of the Arctic, what they call the North Slope. But it's still cheaper than having that thing shut down for 24 hours or 48 hours. So that's a prime example of those kinds of applications. But for that matter, it can even be, we have a military contract currently, and one of the things that we're investigating is using the aircraft for CASEVAC, casualty evacuation, or really medevac is what it is. There's a difference between medevac and CASEVAC, but this is a prime example. The aircraft would be able to take two LD1 containers, the size of a container that's two LD1s put together, and in there is an entire medical suite. And so we can take 6 casualties plus 2 medics, plus all the equipment that they need to sustain life and everything else, and just load it on board the aircraft and send it to pick up casualties and bring them back. And that's a prime example. So these are new things that we're getting more, and with every year that passes, we get more and more applications that our customers can think of. Everything, even from search and rescue. One of them was, we have somebody calls on a sat phone from the middle of the Amazon, and they're in torrential rains and in danger of being overrun, or they can't find their way or whatever. To be able to locate them via that sat phone and land and provide them shelter, up to and including moving them out if need be. Those are things that are really, our customers are the ones that are coming up with these kinds of scenarios and these kinds of use cases. And for that matter, one of the reasons is because we can carry such a large load. If we were even just talking 1,000 pounds, it would be very difficult to do. But because of the fact that we're talking many thousands of pounds, like you said, 5,400 pounds in a VTOL, that really all of a sudden, that's a huge game changer. It provides, you can take off with not only life-saving equipment, but food, medicine, first aid equipment, everything you need, including communications equipment to keep somebody safe in the meantime. So there's a lot of practical applicability to this.
It's very interesting that the market demand is actually not only asking for goods to be transported, but also people as well. So in a way, you kind of gone full circle with your career. Let's talk a little bit about the maintenance. So when we think about these private charters or cargo planes, the kind of the more legacy, operational costs and maintenance costs, and just having crew on standby is very expensive. How are you guys looking to disrupt that portion in terms of the OpEx?
Well, it wouldn't have been just enough for us to invent an aircraft that could fly anywhere and deliver cargo. You're right. If the expense was high, if we were even $1,000 an hour, it'd be, operating expense would be extremely, it would be a non-starter, quite frankly. It just doesn't make sense to do that. So everything, we started from the ground up as well. How is this aircraft going to be maintained? How is it going to be operated? And so a lot of that, even the fact from a maintainer viewpoint, once a year, I always had to take my number one aircraft, the one I started which was a Cessna 421, a twin engine aircraft. And it was it was dead to me for a week. I just couldn't use it because it was being inspected on its annual inspection. Later on, when we added King Airs and things of that nature, sometimes they would have to go in for a phase inspection. And so that phase inspection was, it could take, in some cases, 3 to 4 weeks, and I could not count on that aircraft. If anything, I actually had to replace it, so I had to lease an aircraft during that time period while the other one was down, further complicating the fact that, I'm now not only lost one, but I'm paying extra money now for a leased aircraft. So we looked at that, and Oliver's one of the most brilliant design engineers I've ever met in my life. But one of the things that he said was, the way that we do this is we design an aircraft that's in modules. So we have 5 different modules, and the center wing box, for example, where where all the load is carried, we're going to have to do phase inspections on that. And it could take a long time because they're going to have to physically verify that there are no cracks, which means they're going to have to remove a lot of panels to get in there to verify that there's no cracking, there's no fatigue. How do we do that? Well, we make it to where that section can be removed, another one, brand new one, or a refurbished or an inspected one gets moved in, and we can do that in as little as 24 hours. So now that aircraft that typically would have been, grounded for 3 weeks because of an inspection, now is only grounded for 24 hours while you replace that section. That section that you took out now goes to the maintenance, repair, and overhaul organization, MRO, to have all that work done, and the phase gets done.
Well, that's
so very quick turnaround.
Yeah, fascinating. I mean, from several weeks to 24 hours, and I'm sure you guys are working to even shorten that further. Really significantly changing the process, the workflow, and the cost structure. So with that, I've been joined by Ed De Reyes, who is the CEO of Sabrewing Aircraft Company. Thanks for joining today.
Thank you, Scott. Appreciate it.
If you've enjoyed this episode, take a moment to rate our show on any podcast platform that you listen to. Scroll down to the bottom and push 5 stars. It's that easy. And as always, thanks for listening.